Alright, welcome. Today we're diving into File I/O in Python. And honestly, this is one of those topics that sounds boring until you realize you use it constantly. Reading configs, writing logs, processing CSVs, dumping JSON, it's everywhere. Whether you're a beginner just getting your feet wet or you're somewhere in the intermediate zone, by the end of this, you'll have a solid mental model for how Python handles files. Let's get into it. So everything in Python file I/O starts with the built-in open function. You pass it a file name and a mode, and it hands you back a file object. Simple enough. Now, you can just call open directly and assign it to a variable. That works, but you'd have to remember to call .close yourself. And trust me, you'll forget. That's where the with statement comes in. It's a context manager, and it auto-closes the file when you exit the block, even if something blows up inside it. This is the pattern you want to burn into your muscle memory. Always use with open, always. Okay, modes. When you call open, the second argument is the mode string, and it tells Python what you're planning to do with the file. R is read only. That's the default if you don't pass anything. W is write, but heads up, it overwrites the file. If the file already exists, that content is gone. A is append, which is what you want when you need to add to a file without nuking what's already there. Think log files, and then you've got RB and WB for binary mode. That's for non-text stuff like images, PDFs, audio files. Picking the wrong mode is a classic footgun, especially W when you meant A, so be deliberate about it. Now let's talk about the different ways to actually read a file. You've got four main options. First, .read. This slurps the entire file into a single string. Super convenient, but don't use it on a 2 GB log file unless you enjoy watching your RAM disappear. Then there's .readline, lowercase l, which reads one line at a time. Useful when you're doing conditional processing and don't need everything at once. .readlines, plural, gives you a list where each element is a line. Great when you need random access by index. And finally, just looping directly over the file object. That's actually the most memory-efficient approach because Python streams it line by line under the hood. For big files, that's your go-to. Here's what that actually looks like in practice. We open the file with open, pass it R for read mode, and then just loop over the file object directly. For each line, we call .strip on it. That trims the trailing new line character and any extra white space. Without that, you'd get a blank line printed after every line of content, which is annoying. This pattern right here, with open, loop, strip, is probably the most common file reading pattern you'll write as a Python dev. It's clean, it's memory efficient, and it handles cleanup automatically. Solid default. Alright, writing. Python gives you two main functions here. .write takes a string and writes it directly to the file. One thing to know, it does not add a new line for you. You have to put the \n in yourself. Easy to forget, especially coming from print, which does it automatically. Then there's .writelines, which takes a list of strings and writes them all in one shot. Same deal though. Each string in the list needs its own \n. Neither method adds line breaks for you. Just keep that in mind and you'll be fine. Let's talk about what happens when things go wrong, because they will. The big one is file not found error. That fires when the path you passed to open doesn't exist. Super common when you're dealing with user-supplied paths or relative paths that depend on where the script is run from. Then there's I/O error. That's a broader catch-all for low-level stuff like disk errors or permission failures. And speaking of permissions, permission error is its own exception for when your process just doesn't have the OS level rights to touch that file. The pattern here is straightforward. Wrap your open call in a try except block and handle each case explicitly. Don't just catch bare exception and call it a day. Be specific. Your future self will thank you. So why does Python's approach to file I/O actually stand out compared to other languages? Three things. First, simplicity. If you've ever done file I/O in C++ or Java, you know the boilerplate is rough. Python's version is just readable. You can look at it and immediately understand what it's doing. Second, it's all stdlib. No pip installs, no third-party dependencies. Open is a built-in. It's just there. And third, versatility. That same open function handles plain text, CSVs, JSON, binary data, you name it. You learn one interface and it scales across a ton of use cases. That's very Pythonic. All right, let's wrap up with the checklist. The stuff you actually want to internalize. 1. Always use the with statement. Context managers exist for a reason. Let them do their job. 2. Be explicit about your mode. Don't rely on the default. Write out R, W, or A so your intent is clear to anyone reading the code, including future you. 3. Handle your exceptions. Wrap file operations in try except and catch file, not found error, IO error, and permission error where relevant. And 4. Pick the right read method for the job. Loop over the file for large datasets, use .read for small ones, and reach for .read lines when you need indexed access. Nail these 4 habits and your file I/O code will be clean, safe, and production ready.